we're going to look at a second set of integration problems. Again, we're just getting more practice and being able to look at a problem and know which method we want to be able to use. Okay. The basic idea is you should always see if there is a basic integration rule that will be used flat out. If that doesn't work, the first trick you usually try is a u substitution. In fact, every single one of these is going to make use of a u substitution. In the first one, u is going to be x minus 5 because that is the inside of my exponent. Okay, so du is then just dx, and my integral becomes 14 u to the 6th du. Now the 14 comes along for the ride, and using power rule, the antiderivative of u to the 6th is u to the 7th divided by 7 plus c. In addition to simplifying this to a 2, I also, of course, want to substitute back in what u equals for my final answer. This problem is very similar. Once again, I'm going to let u be the inside of that exponential-like expression. Then du is dx, and my integral becomes 7 over u to the 7th du, which I prefer to write as 7u to the minus 7, so that it is easier for me to use power rule. Here, the 7 will come along for the ride. The antiderivative of u to the minus 7 is u to the minus 6 divided by minus 6, for a final answer of 7 over negative 6 times x minus 10 to the 6th plus c, where again I rewrote the exponential on the bottom of the fraction to get rid of the negative exponents. Okay. On this third one, we're actually going to break up the integral into two pieces. This first one is straight up power rule, so this becomes 1/3 x cubed. To do the second one, I'm going to do a u substitution, where u is this interior piece. So u is 1 minus x, therefore du is negative dx, but I'm going to move the negative sign over to the left. So my integral then becomes negative 1 over u to the 6th du, which I will rewrite as negative u to the minus 6 to make the power rule easier. Now this becomes negative 1 comes along for the ride, u to the minus 5 divided by minus 5. And then I get to clean it up as well as move my exponent down to the denominator again for a final answer of 1/3 x cubed plus 1 over 5 times 1 minus x to the 5th, all plus c. Okay. For my final example, once more I'm going to be doing a u substitution. It's a little bit harder to see what u should be here, but when you have fractions, one of the common tricks is to simply let u be the entire denominator. That would let du become minus 3x squared plus 9, all times dx. Now, this is not what we have. However, notice something. If I factor out a negative 3 from this, I'm left with x squared minus 3, okay? And at this point, I notice a little bit of a typo in my problem. Excuse me about that. You're left with x squared minus 3, which is in fact what we have in the numerator of our problem. So all I have to do is move this minus 3 over to the other side. Okay, and then this is present in my original problem. So my integral now becomes 1 over u times minus 1/3 du. Now, even though this looks an awful lot like power rule, it's not. The antiderivative of 1 over u is ln of the absolute value of u. And then, of course, undoing our substitution by plugging in what u equals gives us our final result for the antiderivative.